Alrighty, next up we want to look at intercept form here. So intercept form of a quadratic function is f of x equals a times the quantity x minus p times the quantity x minus q. And here, the a value is the same a value that we've been messing with before, right? That's the same a value. And then our x-intercepts are p and q. And there's a neat idea there. I'll show you in number 20 how that is, how those are p and q. The vertex, right, this is because of some symmetry ideas, the vertex will always be halfway between the x-intercepts, if it has x-intercepts. So the coordinates of the vertex is going to be p plus q divided by 2. Now that's just the average, right? When you average two numbers, you add them up and divide by 2 because there were two numbers. Right? If you were averaging three numbers, you'd add up the three numbers and then divide by 3. But here we're averaging 2, so we divide by 2. Intercept form can be generalized for all polynomials. And this is kind of a neat idea here, and I want to show you that on a graph. So I made a little Desmos graph here. Up here I graphed in x minus 5, x plus 2, x minus 8, and x plus 0. And then if we look here, that x minus 5, the opposite of negative 5 is positive 5, and there's an x-intercept right there at 5. X plus 2 gives us negative 2, and there's an x-intercept there at negative 2. X minus 8 is positive 8, and then x plus 0 is 0. If I wanted to add in another one, I could, maybe x, I don't know, minus 3, and suddenly our graph now has another spot there right at 3. For us, we're going to look at more simple ones, maybe x minus 2, and then x, I don't know, we'll say plus 2. Just have a nice one. Oops, that is 2 plus 2. We want an x there. There we go. And it has intercepts there at negative 2 and at positive 2. So that's more of what we're going to be doing. Let's go back to our notes. So intercept form can be generalized for all polynomials, and we'll use that sometime, I think, later on in our notes. We want to remember that the idea or the terms 0, solution, x-intercept, and root, those can all be used kind of interchangeably. They all have different connotations with them, right? Normally, if you're talking about an x-intercept, you're referencing a graph. Whereas maybe if you're referencing a solution, you're looking at an equation. They're very similar. There's a little bit of a difference, but we can normally use those interchangeably. Whenever it says to find the zeros of a function, that means to find the x-intercepts of a function, right? So whenever we are doing our homework or other math problems, if the term confuses you, then just kind of replace it with a different one and see if that makes it a little bit better, right? All of these terms here, you could interchange whenever it's asking you to find them. So find a 0 is to find a solution or to find an x-intercept. Number 20. I'm going to start off by looking for the x-intercepts of this. Then I'm going to graph it. Then I'm going to look for the vertex. So starting off, and you don't necessarily have to do this very beginning step, but whenever we look for an x-intercept, that's always going to be of the form x comma 0. Right? You're always going to have an x, and then you're going to have a 0 for our y. This is kind of like the way in the last video that I would find my y-intercepts. So here, if the y is 0, I'm going to set this equation equal to 0. 0 equals x plus 4, x plus 1. Now we can use what is called the zero product property to take this guy and break it up and set them equal to 0. This is because 0 equals two things multiplied together. And if you have two numbers that are multiplied together and they equal 0, then one of them or both of them has to be 0. So I can say x plus 4 equals 0 or x plus 1 equals 0. And then this, whenever I solve, gives me x equals negative 4 and x equals negative 1. These are my x-intercepts. Those are my x-intercepts. Right here we can see that they're the opposite of what was listed. This is a negative 1 and a negative 4 versus the positive 4 and the positive 1 in the original. It will always be that way. It's where it's the opposite. So up here, our x-intercepts being p and q, it's p and q because they listed a negative p and a negative q in our formula. Back down here, we got our x-intercepts, and we could go ahead and graph that if we wanted to, just our x-intercepts. negative 1, and then 2, 3, 4. Now we really want our vertex here, and our vertex will happen halfway between them. So our vertex happens halfway between. That's going to be negative 4 plus negative 1 divided by 2. That's going to give me negative 5 over 2, which we'll go ahead and say is negative 2.5. So our vertex, he has an x value of negative 2.5. And if you look at our graph, negative 2.5 is going to happen halfway between there. So we could also say this is our axis of symmetry. So our symmetry is going to be at x equals negative 2.5. Now, much of the rest of the problem is going to be kind of similar to back to our standard form, where we're going to plug this negative 2.5 into our function. So I'm going to say f of negative 2.5, that's equal to negative 2.5 plus 4 times negative 2.5 plus 1. This is going to be, what, 4 minus 2.5 is 1.5. And then over here we'll have negative 1.5. And I'm thinking that's 1.25, but let me type that in just to make sure. Yeah, 2.25, oops. So this is going to be negative 2.25. So I can copy this over to my vertex, negative 2.25. And I can go ahead and graph that. I need to go down 1, 2. I'm going to put a 3 mark there, and we're just going to be somewhere between them. I'll go ahead and draw in my curve there. And a good thing to mention about these is whenever we're doing intercept form, and this is an intercept form, I am happy with us just doing 3 points on our graph. 2 x-intercepts, and then 1 vertex. Okay. Now, our a value here is 1, and you could use the 1 and 4 like we had done previously if you wanted to. That is also just a good way to do it, but I'm happy with doing the 2 x-intercepts and our vertex. All right, let's make sure I wrote everything down that we needed. We want the vertex, the symmetry line. We need a maximum or minimum. This one's going to have a minimum down here, so our minimum value is going to be y equals negative 2.25. Negative 2.25, and that comes from the y value of my vertex over here. My domain is again going to be all reals. And again, and I know I've said it before, but I'm saying it again, the domain is by default when you're doing this style of a problem. You think about it being all reals, and you look for a domain restriction. You look for an even root, that would be like a square root or a fourth root, or you look for an x in the denominator. This has no fraction in it, so there's not the opportunity for the x to be in a denominator. And then also, we don't have any kind of square roots or even roots, so our domain is going to stay all reals. Our range, he's talking about our y values, and it's not going to be all reals. It's going to be everything above, so greater than or equal to our minimum. Lastly, we get our y-intercept. And for that, we're going to plug in 0 for our x. So I'm going to plug in f of 0. That's going to give me 0 plus 4, 0 plus 1. So f of 0 is 4. So our y-intercept is 4. And there we go. That's intercept form. For me, I think intercept and vertex form are the easier ones. And then standard form is normally just a little bit, I don't know about harder, but more tedious, maybe. More tedious. All right, that's number 20. Number 21, we look at that one. And first off, we see negative 2 hanging out front. The negative 2 is like our a value. So the negative means he's going to be facing down, right? So facing down. And the 2 means he's going to be a little bit skinnier than normal. Now, we're not going to have to necessarily use that a whole lot in our problem, like using the 1 and the 4, like what we've done before. But it is good to just consider what is this doing to my graph? How is it going to make my graph look? So starting off with this style, we want to say our x-intercepts, it's the opposite of what is listed. So here we have a -2 and a -10, so it'll be a +2 and a +10. And we could go ahead and graph that, but I'm going to find my vertex first. My vertex is going to happen halfway between them. So halfway between 2 and 10, you add them up and divide by 2, that's 12 halves, which is 6. So that gives me the first value of my vertex, the x value of my vertex. And then I plug in the 6, and that gives me -2 times 6 minus 2, 6 minus 10, -2 times 4 times -4. And what's that going to be? +32. F of 6 is +32. So my vertex is at 6, 32. And you know what? Let's go ahead and write out some other factoids for our, some other characteristics. Factoids, you know. You could call them that if you want. This guy's going to have a maximum, and I know that because of this -2. So he's going to be facing down. So we're going to have a max value of y equals, and then I pull this 32 from my vertex. My domain will be all reals. My range, well, I've already said I have a max, so it's going to be y is less than or equal to 32. Lastly, I'm going to get my y-intercept before graphing. Y-intercept. I'm going to plug in f of 0. So -2 times 0 minus 2, 0 minus 10. -2 times -2 times -10. That's going to be what? -40. So my y-intercept is -40. Now we'll go and graph. My x-intercepts are at 2 and 10. And then for my y values, I'm just going to say there's going to be 10, 20, 30, and I'm going to go a little bit higher. So what is this? 2, 3, 4, 5, 6. There will be 6. So we'll be right in that region right there. Oops, I guess I should be a little bit higher than that, shouldn't I? And I'll draw in my curve. And there we go. All right, that's 21. Let's look and see at our next one, 22. All right, now we shift gears a little bit, and this is going to be referencing the bottom part here. Where is it? Oh, right here. Intercept form can be generalized for all polynomials. So we have the a value out front still, and then we just have 1, 2 sets of parentheses for quadratics. For a cubic, we're going to have 3, and then for one with 4, we'd have 4 or 5 or 6. Down here, on our next page on 22, we're doing cubics. We're going to have 3 sets of parentheses. So they just say to write a cubic function. It doesn't say write a. So we're just going to say that our a value is equal to 1. Right? And that makes our problem a little bit easier there. So we're going to have y equals a, which is 1. And then I just have a set of parentheses for each of my 3 roots. I'll say x minus 0, x minus 1, and x minus 7. Remember, it's the opposite of what is listed. If the root is +1, then listed will be a -1. Now right here, this x minus 0, that's kind of ugly. We're going to make it a little bit prettier. Y equals just plain old x, and then x minus 1, x minus 7. If you wanted to, you could put any number you like right there. You could put like a 21 right there, and it would still have those characteristics. It would still have the x-intercepts or the roots at 0, 1, and 7. All right, there's 22. 23, use zeros to graph the function. This is a cubic function. This is going to be a little bit different. Because it asks for zeros, we're going to want it in factored form, which is intercept form. So the first task here is going to be to try to factor this. all three pieces have an x, so I'm going to pull out an x. So I'm going to say f of x equals x times x squared plus 16x plus 28. So I pulled out an x. Then I'm going to try to factor. So we have a 1 out front, so a times c, that's going to be 1 times 28. That's still 28. Then we want two numbers that multiply to be 28 and add up to be 16. 16 is our b value here. So what's that going to be? 14 and 2. Positive 14, positive 14, and positive 2. Those add up to be 16, and they multiply to be 28. So we're going to now break this apart to be f of x equals x times x squared plus 14x plus 2x plus 28. So these two middle guys, I just broke that 16 apart. And now that they're broken apart, I can factor by grouping. So I'll have the first two and the second two. So now I'll have x times, you know what, I'm going to use a bracket there. A bracket's just a fancy parenthesis. In my first two, I want to factor out an x, and I'm left with x plus 14. And then in my second two, I want to factor something such that my parentheses will be another x plus 14. So I'm going to factor out a 2, right? And we can always check ourselves by kind of thinking about plugging back in or redistributing, and we would have what we started off with. Now, they both have in common the x plus 14. So in my next step, I'm going to be able to factor that out. So I'll have my x, then I'm going to pull my x plus 14, and then left over, after I pull out that x plus 14, is the x, that's this x right here, and then the 2, x plus 2. So now I'm going to drop those brackets because those are no longer needed. So I say f of x equals x times x plus 14 times x plus 2. And there's going to be our function. Now we want to try to graph that. We're going to graph using the intercepts. We have three different intercepts here: 0, negative 14, and negative 2. So I'm going to put a dot on 0. Negative 14 is going to be pretty far off to the left. That's going to be negative 14. And then negative 2 is going to be a little bit closer. All right, I'm just going to do a rough sketch. Because this guy is cubic, I know his end behavior is going to look like this. Right, falls to the left and rises to the right. So I'm going to put my little arrows on here. Falls to the left, rises to the right. And now I'm just going to try to connect the dots. Oops, that was not very nice. Hold on. If I can draw this in correctly, that'd be nice. There we go. It's going to be something like that. That's not perfect, but whenever we're graphing with intercepts, oftentimes we only care about those actual dots where it's at 0. And then the rest of the curve just kind of falls into place. So there we go, that's 23. If we wanted to be more precise on 23, we would make a t-chart, an xy t-chart, and we could plug in some points. Maybe we'd plug in the point -1, and then we could get a good answer there, a good solid point there. But for this, for 23, and for any problems on the homework that are just asking you to graph like a cubic or anything higher than that, I am happy with just some dots and then connecting the dots. The dots being the x-intercepts, and then connecting those with a curve. Alrighty, that is 23. Is that the end? That is the end. All right, that was section 5. And that is, what was that called? Intercept form. There was intercept form.